Hello students, welcome back. I am Rinkesh sir, and today we will start with exercise 9.4 of chapter number 9, that is sequence and series. Okay, so let's start with question 1. Question 1. It's given that you have to find out the sum of two n terms. So find the sum to n terms of each of the series in exercise 1 to 7. So for question 1 to 7, you have to find out the sum to n series. Now say question 1 is 1 into 2 plus 2 into 3 plus 3 into 4 plus 4 into 5. So here there are two series given. 1, 2, 3, 4. These terms. Okay, and the other is 2, 3, 4, 5. Okay, now see here I will take the first term is equal to 1, difference is equal to 1, right? So for nth term it will be a means 1 plus n minus 1 d, that is 1. So 1 plus n minus 1, that is equal to n. So the first series can be determined by n. For second series, the first term is 2. The difference again is 1. So this can be determined by a, that is 2 plus n minus 1 into 1. So 2 plus n minus 1, that will be equal to 1 plus n. So the second series can be determined by this way. Okay, so now I can write it down that the sum is first series summation of n, okay, an into an dash when n is equal to 1 to n. Okay, so this will be equal to summation of an, that is n, and an dash, that is 1 plus n. Okay, so this will be equal to summation of n into 1 n plus n square. Okay, so now I can separate this as summation of n plus summation of n square. Now see, the formula for summation of n is equal to n plus 1 by 2. The formula for summation of n square, that is n plus 1, 2n plus 1 by 6. And the formula for summation of n cube, that is equal to n square m plus 1 square upon 4, means square of this we will get summation of n cube. And one more thing, if there is a constant like summation of a, okay, then it will be equal to an. Okay, means if you are adding a n times, then it will be an. Okay, now let's start. So from here I can write down Sn. Summation of n means n plus 1 upon 2. Summation of n square, that is n plus 1, 2n plus 1 upon 6. So now first let's see what we can take common. We can take n common in both, n plus 1, even 2. So what is remaining here? 1 plus. What is remaining here? 2n plus 1 upon 2 3s are 6. Okay. So now solving it further, this will be n plus 1 by 2. Taking LCM, 3. 3 plus 2n plus 1. So Sn will be equal to n plus 1. Here it will be 2n plus 3 plus 1, 4 upon 3, 2 into 3. Now see here I can take 2 common. Let's take 2n, n plus 1, this will be n plus 2 because I have taken 2 common upon 2 into 3, 2 gets cancelled. So our final answer will be Sn will be equal to n, n plus 1, n plus 2 upon 3. So the summation of two n terms in the given series will be n, n plus 1, n plus 2 upon 3. Okay, so this was about the first question. So just note it down. Okay, remember this formula for summation. Now note down question number 1. Now let's move ahead. Question number 3. It's 3 into 1 square plus 5 into 2 square plus 7 into 3 square and so on. So the first series is 3, 5, 7 and so on. So A equal to 3 and the difference is equal to 2. So the nth term will be equal to, let's say A and S first. That will be equal to A plus n minus 1 into 2. So 3 plus 2n minus 2. So it will be 2n plus 1. The second series is 1 square, 2 square, 3 square and so on. So here we can directly write it down that this is equal to n square. Okay. So now the required series let's say nth term series, that will be an dash into an double dash. So what is an? 2n plus 1 into n square. Clear? So this will be 2n into n square, 2n cube plus n square. Okay. So now the series will be equal to summation of 2n cube plus n square. Let's separate it. Summation of 2 is constant, so I can take it out. Plus summation of n square. So for n cube, the formula is n square, n plus 1 square upon 4. And for n square, it is n, n plus 1, 2n plus 1 upon 6. Here I can cancel 2 ones are 2 2s are. So now let's take common. What I can take common here? 1n, n plus 1 and from here 2. So n, n plus 1 upon 2. So what is remaining here? N into n plus 1 plus 2n plus 1 upon 3. So n, n plus 1 upon 2 into n square plus 1 plus 2n plus 1 upon 3. Clear? Now let's take LCM. So Sn will be equal to n, n plus 1 upon 2. What is the LCM? The LCM will be 3. So 3 into n square, 3n square. 3 into 1, 3 plus 2n plus 1. Now this will be equal to n, n plus 1 by 2. LCM is 3. So 3n square plus 2n plus 4. Okay. Sorry, there is some mistake. Mistake is when you multiply 1 by 3, it will be 3n. So this will be equal to plus 5n, 3n square plus 5n plus 1. So final answer Sn. Okay, 3 to the 6. So n by 6 into n plus 1 into 3n square plus 5n plus 1. This is the answer. Okay, so this was about question number 3. So just note it down. Now let's see the next, that is question number 4. Question number 4. 1 upon 1 into 2 plus 1 upon 2 into 3 plus 1 upon 3 into 4. Okay, now see here. Let me write down the question first. 1 upon 2 into 3 plus 1 upon 3 into 4. Now see, we need to do rearrange. See, 1, 2 consecutive number, 2, 3 consecutive number, 3, 4 consecutive number. So see, I am taking example 1 by 1 minus 1 by 2. When I take LCM, it will be 1 into 2, 2 minus 1, so 1 by 1 into 2. When I take 1, let's take any two consecutive number. Let's take 7 and 8. So this will be 7 into 8, 8 minus 7, this will be 1 upon 7 into 8. Right? So, as there are two consecutive numbers, we can rearrange it like this way. 1 upon, sorry, 1 by 1 minus 1 by 2. I can write a 1 upon 1 into 2 in this way. See. Plus. Similarly, how can I write down 1 upon 2 into 3? 1 by 2 minus 1 by 3. Similarly, 1 by 3 minus 1 by 4. Okay, this is just for example. And the final will be, it will be, see, first bracket, second bracket, denominator is 2. Third bracket, denominator is 3. So for nth bracket, it will be n minus, which will be the number just next to n, n plus 1. Okay, so now see here what will happen. 1 by 2 will get cancelled with this, minus 1 by 2 plus 1 by 2, minus 1 by 3 plus 1 by 3, minus 1 by 4, it will be like this, and finally this will be getting cancelled. So see, if in the first bracket first term is existing, then the last bracket second term, last term will be existing. So all the terms inside will be getting cancelled. So finally I will get 1 by 1, that is 1, minus this last term, that is 1 upon n plus 1. So solving this, taking LCM, it will be n plus 1 minus 1 upon n plus 1. So here the sum of this series will be equal to 1 will get cancelled, n upon n plus 1. Okay, so this was about question number 4. So just note it down. Now let's see the next, that is question number 5. Question number 5. It's here to find out the series, that is Sn. Sn is equal to 5 square plus 6 square plus 7 square up to 20 square. Now see, when I have given you the formula like n square equal to n plus 1 2n plus 1 upon 6. Now see, this formula says that it is starting from 1, means 1 square plus 2 square plus 3 square up to n square. But see here, it is starting from 5. So I cannot use this formula. So see what rearrangement I am doing. I am writing this 5 square plus 6 square plus up to 20 square. This is the given series. But if it was from 1 square, then I would be able to use this formula. So what I am doing, 1 square plus 2 square plus 3 square plus 4 square plus. I had added this. This is the additional thing which I had added. So what I will do, I will also subtract it. Means minus 1 square plus 2 square plus 3 square plus 4 square. See, whatever I have added extra, I had also subtracted it. Clear? So now, if I take this, then what I can write it down? 1 square plus 2 square plus 3 square up to 20 square minus 1 square plus 2 square plus 3 square plus 4 square. Now I will be able to use this formula, right? Because in both the bracket, it is starting from the first term, that is 1. Okay, in this case, n is equal to 20. In this case, n is equal to 4. So this will be equal to n plus 1. N means 20. N plus 1, 20 plus 1. 2n means 20 into 2, 40 plus 1 upon 6. Minus n equal to 4, that is 4. N plus 1, 4 plus 1. 2n plus 1 means 4 to the 8 plus 1 upon 4. Okay, so this will be 20 into 21 into 41 divided by 6 minus 4 into 5 into 9 by 4. Okay, so let's calculate. 20 into 21 into 41 divided by 6, that is 2870. It's 20. So 2870 minus 9 5 is 45, right? So Sn will be equal to 2840. Sorry, 2870 minus 45. See here there is one mistake. Here it will be 6. So 4 will not get cancelled. Okay, let me change it. This will be 4 into 5 into 9 by 6. So let's find out. This is 2870 minus 4 into 5 20, 20 into 9, that will be equal to 180. So 180 by 6. So 2870 minus 180 upon 6. 2870 minus 180 divided by 6, that is 44. Sorry, again there is one mistake. It's 2870, not 2870. We are already divided by 6. 20 into 21 into 41, 17220 upon 6 minus 180 upon 6. 17220 minus 180 upon 6. So minus 180 divided by 6. It's so 17220 minus 180 divided by 6. That is equal to 2840. Okay, so required series is 2840. So this was about question number 5. Just note it down. Now let's move to the next, that is question number 6. Question number 6. It's 3 into 8 plus 6 into 11 plus 9 into 14. So the series of all the first term is 3, 6, 9. The next is 8, 11, 14 and so on. So the first term is 3 and the difference is 3. So the nth term will be a plus n minus 1 into d. So 3 plus 3n minus 3. This will get cancel, it's 3n. In the other series, the first term is 8 and the difference, that is 11 minus 8. Again, that is equal to 3. So a n double dash, that will be equal to 8 plus n minus 1, 3. 8 plus 3n minus 3. So this will be 3n. 8 minus 3, that will be equal to 5. So 3n plus 5. So the required series an will be equal to an dash into an double dash. 3n into 3n plus 5. So 3 into 3n into 3n, 9n square plus 15n. Okay, so the sum of this series will be summation of 9n square plus 15n. 9 as it is constant, I will take outside, summation of n square plus 15 summation of n. 9 summation of n square n plus 1 2n plus 1 upon 6 15 n n plus 1 upon 2. So I can write down 3 threes are 3 twos are. Clear? Now let's see what we can take common. I can take n plus 1 and 2 common. What is remaining here? 3 into 2n plus 1. On this side, 15. So n plus 1 by 2. 3 twos are 6n plus 3 plus 15. Okay, so this will be equal to n plus 1 upon 2. 6n plus 15 plus 3 18. Now I can take 6 common from these two. So 6 I am taking common. So n plus 6 threes are 18 upon 2. So 2 ones are 2 threes are. So the sum of the required series is n 3n n plus 1 n plus 3. Okay, so this is the sum of the required series. So this was about question number 6. So note it down. Question number 9. Find the sum to n terms of the series first ninth n square plus 2 raised to n. Okay, so question 9 is given n square plus 2 raised to n. Okay, so now Sn is equal to, I can just separate it, summation of n square plus summation of 2 raised to n. So for n square, the formula is n plus 1 2n plus 1 upon 6. And for 2 raised to n, I can write down 2 raised to 1 plus 2 raised to 2 plus 2 raised to 3 up to 2 raised to n. Okay, so this will be equal to n plus 1 2n plus 1 upon 6, just a minute, upon 6 plus. Now see here, this is geometric progression. Okay, where a the first term is 2, the ratio is 2 square by 2 equal to 2, and the last term is n. We'll use the formula like a r raised to n minus 1 upon r minus 1. So I can write it down here as a, that is 2 ratio 2 raised to n minus 1 upon 2 minus 1. Final answer will be n plus 1 2n plus 1 upon 6 plus 2 into 2 raised to n minus 1. Okay, so this was about question number 9. So just note it down. Now let's move to the next and the last for this exercise. Question number 10. Now here the series you have to find out whose sum of the nth term is 2n minus 1 whole square. So squaring it, I will get 4n square minus 2ab, that is 2 into 2n into 1, that is 4n plus 1 square. So Sn will be equal to summation of 4n square minus summation of 4n plus summation of 1. Okay, so 4 is constant, summation of n square n plus 1 2m plus 1 upon 6 minus 4 summation of n, it's n plus 1 upon 2 plus summation of 1 is 1n, so that will be equal to n. Clear? So now let's see what we can take common. Okay, from the first two I can take 4 common. Okay, and in denominator 3 common, so 4 by 3. I can take n common, I can take n plus 1 common. So remaining is here 2n plus 1 by 3 minus, I have taken 4 common and n plus 1, everything I have taken common. So this will be equal to 1. Okay, plus n. Clear? So now this will be 4 by 3. Sorry, here it will be not 3, we have taken 2 common, not 3. That will be 3. So it's 4 by 2 and n plus 1. This will be equal to 2n plus 1 minus 3 upon 3 plus n. So carrying it forward here, it will be 4 by 2 n plus 1. It will be 2n minus 2 upon 3 plus n. Clear? So I can take here 2 common. So 4n n plus 1 upon 2. I can take this 3 also outside. 2 common. So it's n minus 1 plus n. 2 gets cancelled. So it will be 4n by 3 into n plus 1 n minus 1, that is n square minus 1 plus n. So now again I can take n common. Okay, so it will be 4 by 3 n square minus 1 plus n. Taking 3 as LCM, I can write it down n 4 into n square minus 4 into 1 4 plus 3n. Okay, so now, so sorry, here we are making a mistake. We have taken n common, so it will be 1. So it will be not 3, it will be 3. So this is n. 4 I can take common. Okay, or else let's write out n by 3 4n square minus 1. So a square minus b square, So this implies Sn will be equal to n by 3, 2n plus 1, 2n minus 1. Okay, so this is the answer of question number 10. So just note it down. Okay, students, so here we complete exercise 9.4. That's it for today. Thank you.